And just like that, it's me, John Park, here in John Park's workshop. Can you believe the odds? Yes, it's true. Here I am. And apparently, so are you. It's very nice to have you today. And thanks for anyone who's stopping by over in the Discord chat and the YouTube chat. Nice to see you. Also, thanks everyone for stopping by Facebook and Periscope and Twitch. I'm not in those chats, but hello. We're a little clippy here. Ah, that's interesting. I'm getting my minus 9 dB average and minus 2 dB peak reported by C. Grover. Thank you. And sometimes I lean down into the mic and definitely clips in those cases. So I'm just going to turn that down a little bit. We have an action-packed show for you today. First of all, Perfect Circuit Audio changed their logo, so I had to go get, this is their old logo, I had to go get a t-shirt with the old logo on it because now it's a collector's item. They're my local synthesizer shop, serving Southern California. So that was exciting news, but their new logo is very cool, so I might get one of those too. Who knows? Let's see, what else have we got? Let's jump into a coupon code. How about that? There you go. It's a trap. It's a trap. It's a trap. Today we're going to be talking about a trap, a prank jump scare trap for Halloween. And the word trap started to jump out at me as a weird word, so I had to use it. It's a trap. That will get you 10% off in the Adafruit store today until midnight tonight on some coast. I'm not quite clear where. Maybe the East Coast's midnight. And that's good for all the great products that you can get in the Adafruit store other than gift certificates, subscriptions, and software. It's a trap. Yes, that's right. That will get you 10% off. And I'm going to show you some cool stuff that you might want to consider getting. First of all, let's jump to that. Look, product of the week. Product of the week is Get ready for it. That is the Neo Trellis, the 4x4 RGB button pad driver with the added elastomer buttons. So I just got one, and these are hot off the press. We might be sold out at the exact moment, but I'm sure we'll be back in stock soon on these. This is just like the old Trellis that you may know and love, except now it's got RGB, right? Red, green, blue, your favorite 3 primary colors, in NeoPixel format. So these are buttons that you can press. I've created a little demo thing here. So I boot up and get some animation, and then when I press buttons, I get different colors on these buttons, which is super cool. I even did a bonus. That button clears it. So it's very easy to program. I programmed this in CircuitPython last night in about, I don't know, 20 minutes when I said, ooh, I know what I want to make to show off this product tomorrow. I put this thing together. So I've also got a little 3D printed cover from the Ruiz brothers from one of their previous Trellis projects. And these not only can light up and do fun effects when you press them, but they're actually a really cool interface. So anything you can interface a microcontroller with, those buttons could be part of the fun with a Neo Trellis. One thing that I think is pretty interesting is sending out USB keyboard or mouse over these and MIDI control. I'm thinking about using it in a Eurorack synthesizer module at some point, especially because the addition of color gives you a lot of user interface. So if we have, let's say, knobs or switches or signals coming in that are altering the colors of the buttons, that can be meaningful info, which you can then act upon to do cool stuff. Let's see, let me turn it off and on. I think I've glitched something on it. Like I said, I wrote the code pretty quickly, so maybe it's got problems. But you can write the code in CircuitPython like I did here, or in Arduino. So that's the Neo Trellis. Everyone's been asking for these for a long time. Once the regular trellises came out, people said, what about RGB color? Well, now we have RGB color. It's super cool. And I'm running that, I don't know if I mentioned this, I'm running that on an itsy bitsy M4. That doesn't really want to focus. Let me put my face there. Focus! Doesn't want to focus. The itsy bitsy M4 is a pretty good choice for this, I think. You can run it on pretty much any microcontroller. But I like this one because we have 2 DACs, 2 analog output, 10-bit analog outputs, which could be useful for drum machine kind of stuff or sequencer kind of stuff. Yes, and someone mentioned that could be handy for DAW work, digital audio workstation work. I definitely am interested in using Bluetooth with this. I know there are people who have linked multiple of these together with the previous Trellis. You can see here we've got little bridge attachments to make multiple pad arrays, and they just each need a unique I2C address. And once you do that, you can send all kinds of different information to a piece of software like a digital audio workstation or an animation workstation or a programming interface of some kind. So yeah, these are hot off the press, so look for interesting uses. Dave Estelle said he has not yet figured out what to use it for, but he wants to. Well, that's perfect, right? That's the spirit of all of this. I don't know what I'm going to use it for, but dang, that thing's cool. How am I going to use that? All right, let's see what's next. I think we're ready. I think we're ready for this. Are you ready for this? Yes, that's right. It's the Make Code Minute. And on today's Make Code Minute, I wanted to talk about using the Circuit Playground Express with Make Code as a USB keyboard. So what you'll see here, let me bring up my little Circuit Playground Express. You can see right there, green screened out. So what I have going on in this code right here is just 2 very simple things. I have 2 on button press events or button click events. So on button A, I am going to type the word hummingbird. And then on button B, I'm going to type the words rocket pants, right? So you could type single letters, you can type function keys, media keys, up and down arrows, but I've chosen to use it as sort of a helpful little input device. So I'm going to switch to something where you can see some text input. Where did this go? I don't know where that screen went on my, there it is. Okay, so here you can see I'm writing a letter to Phil, and I say, hey Phil, it is time to deploy, and then I'm just going to press one button, Rocket Pants. And you can see to take over the donut shop. That place is full of, and I'm going to hit the other button, hummingbird. Hummingbirds? Let me move this out of the way. Hummingbird. I got to go back and add an S. Okay, so that's kind of a silly example, but you can see that using make code and these little USB keyboard input blocks, you can do a ton of stuff. So the way I've set this up is by clicking on this advanced tab and choosing extensions. From here you add USB keyboard, and that gives you this category of blocks. So you can type in a command, you can hold a key down, and then you can do these media keys I mentioned, like volume up and down or mute, and function keys as well as page up, page down. So there's a lot of interesting things that you can do with a keyboard entry, from things like light levels, tilting the Circuit Playground Express, the buttons like I've shown you, and so on. So that is our Make Code Minute. What do you think of that, huh? I don't have a text thing up in here, or I would just type Hummingbird Rocket Pants all day long. I don't know why. Ooh, over in the, oh look, someone's ringing the door. I'm gonna go close, I'm gonna turn off, I have a little ringer here that I can unplug because I don't want to hear, maybe that's a package, maybe a package came, who knows. All right, this is turning quickly into Mr. Rogers' neighborhood if I start getting mail persons coming. Over in Discord chat, Mr. Certainly has come up with Rocket Pants hummingbird icons, sort of. Rocket Pants, Rocket Jeans Cardinal? Rocket Jeans Cardinal. Hummingbird Rocket Pants is pretty niche. Yeah, not a lot of people like those guys, especially their earlier experimental stuff. I'm kidding. Okay, so let's see, what do we got next? Oh, speaking of, close that thing. Speaking of interesting Rocket Pants, hummingbirds, and music stuff, the piece that I was playing on the intro to the show, one of the things that I did, I made that with a modular synthesizer and a little pocket drum machine. But at one point, I'm using a kind of new module that I have that I wanted to mention. This is outside of, this is a little left field, but let me pop this up. So let's see. Okay, over on, that's my personal blog, and over there I reviewed this thing, the Euroshield. And what this is it's a adapter for Teensy into Eurorack that uses Arduino and all the really cool Teensy audio libraries. One of the reasons I mention this is that I'm really hopeful that we will continue porting some of that audio library stuff over to Feather microcontrollers maybe, or Itsy Bitsies, and maybe into CircuitPython eventually. But right now I'm using that module to essentially program stuff that you don't have a module to do. So you can create modulators like low frequency oscillators, you can do effects, and I'm going to show you a little quick example here where you'll see when I plug in a patch cable into the Euroshield module there, it's going to start doing a delay, kind of doubling all the notes. So check this out. Okay, so you get the idea. So anyway, that thing is pretty cool, and it's exciting to see this merging of worlds with microcontrollers and analog. A lot of that is analog music gear as well as some digital gear, but the language that's being spoken on that rack is 1 volt per octave control voltage for pitches, and gates that are like little pulse signals. So it's not too hard to interface that stuff to microcontrollers, and that little Euroshield module is a very cool way to do that. Full disclosure, I was given that to help beta test it by Aaron Higgins of 1010 Music, because I bumped into him at a synthesizer meetup thing. But I think it's a very, very cool module, and it's exciting to see something like that that's really meant for DIY stuff. So that's the tool tip of the week on something related to our spheres of interest, I think. And let's see, that is actually a perfect time to move into our project build. So the project build this week, I'm going to bring it over here. I'm using this setup again just because it's helpful. I have some of these projects that are kind of an overhead thing. I built this last week to show that, hi, let me get rid of this thing. There I am. Oh. To show the electromagnet in use. But what you can see here, I'm going to plug this in and it's going to go through some boot up stuff. This is a HalloWing jump scare trap. And what you're going to see is I'm using the HalloWing and its screen as an interface. So right there it's saying, please stand by as it readies the system. It has just set the trap. Oh, the trap just went off, darn it. So I'm in front of the IR sensor. Let me try to move that. I'm gonna hide over here. And what you're gonna see is, so there's an infrared sensor over on this side, the back side here, that's watching for trick-or-treaters to come up to your porch. It's facing outward, so I'm gonna pretend I'm inside. So I have just pressed the reset, and it's going to delay for a little bit to make sure we're clear of IR sensing. Okay, the trap is set, and I'm going to try to not. Okay, so my idea here is, let's see, I've got this kind of on the wrong side. Let me swing that over. I've got a little creepy crawly. This is a rubber cockroach, but you could use spiders or eyeballs in a bucket or whatever you want. I'm hanging that just on a little servo motor. And now I have a little thing shielding the PIR sensor. I'm going to try to remove that without disturbing it. Oh, and I disturbed it. So you can see now that's it's going to make a hissing sound. It's going to drop that cockroach in front of their face on fishing line. I'm just going to unclip that and show you the other side of it. So what I have here is, you can see there's the PIR sensor poking out. You may remember this from my eyeball in the skull build. So that's a PIR sensor. And what I'm doing is I'm shielding it so that someone walking up from the side isn't going to trip it. It's only when they get in front of it. So these normally have like a, I don't know, like a 140-degree field of view or something like that. There's a Fresnel lens in here, so it's collecting IR signal from all over the place. And so what I'm doing is I'm just with a little piece of paper cone there, you can see, or tube, I'm limiting that to in front of and slightly below. And then that board is actually back here feeding into the sensor port on the HalloWing. So HalloWing is great for this kind of project because it's got input for a sensor like this. We're actually using it as a digital sensor. It either sends a high or a low signal when it sees a human or a large enough mammal, something full of heat. And then I've got the servo motor plugged into one of the, I think I've got it plugged into the NeoPixel output actually, because that'll give us a good 5 volts. And then I've got the speaker plugged into the speaker port. And what I've done, let me switch over to code window here for a second. Let's see, do I have a code window? Where are you? Oh, did I not make a code window? I don't think I did. All right, let's make one. You'll lose my audio for a second, but hang on. I will show you in CircuitPython what this looks like. Oops. Stand by. And here we'll grab a screen capture from a window. And I'm using Atom. Here's Atom. Perfect. You can tell this is really live. Bring my audio back up. There we go. Okay. So this is what the code looks like to, I can pop this back up here so you have a little something nice to look at as we go through the code. So in CircuitPython, the kind of key things are, for me to do this project is last week I had done, oh, you can't see that there. I had done the, a badge image viewer. I just put that guide up last week. And so I got familiar with using CircuitPython to bring up BMP images. So I'm not talking to this screen like it is a, try to move this out of the way. There we go. How's that? And you can still hear me, yeah. There we go. Good. So what I'm using is BMP images that I created, which are showing these things like reset the trap, which you see written on there right now. I'll hit this so you can see it's going to now switch to please stand by while it's waiting a certain period of time. So what I'm doing in code here is I'm bringing in the necessary libraries to do touch I/O, to tap those capacitive touchpads. I'm bringing in pulse I/O so I can talk to servos, audio I/O so that I can play the beeps and the hissing sound. So I got a whole bunch of these little things going on. There it goes, running again. And I won't go through every little bit of it, but you can see I'm setting up a servo so that it can go to a minimum and a maximum position. It's just reset itself, so it's raised the servo back up. I've defined a little wave player here that'll play this hissing file that I created. That's actually me and my daughter hissing into a microphone for that cockroach hiss sound. I'm also using pulses for the beep, so that's not a wave file. So this is the pulse setup here. And then I made myself some little helper functions like beep, so I can just later on in code say beep 3 times, beep parentheses 3, and it'll run this sine wave sample. Doing a little countdown. And what's interesting is when I was prototyping this, I was watching the LED. So I have the LED blinking so that I would know if it blinks 8 times, that's because it's getting ready to set up, then it blinks faster, and now it's set up and ready to go. I wasn't using the TFT screen at all, but what I realized is I couldn't see that once I set it up in a more realistic scenario. So that's when I said, you know, it's going to be worth using the TFT screen to have an interface. Why not? It's there. It makes for a very convenient user interface. So here you can see I'm display setup. I'm turning on the backlight and I'm setting it up with a maximum brightness. And then I have an array or a list full of these images that I created: trap sprung, reset trap, please stand by, and trap set. And then I have an image, a little function for playing those images. And let's see, that's all startup beeping, and it prints some print statements. If you're plugged into the computer, you can look at those. And then this is the bulk of what actually happens in the code. Let's see, can I fit it all here? Almost can fit it all here. All it does is it watches the pin that the PIR sensor is plugged into, and when that is not triggered, it doesn't do anything. When it gets triggered, then we're going to play the wave, which is that hissing sound. We're going to switch images to the one that says please reset. We're going to blink and count down, and then we're going to go into a, I might have to raise this up, or I can let me put some carriage returns here. Raise that up for you. And then once it's played, we're waiting for this ready variables what gets switched when I touch the touchpad, and that's what switches it then to show that setting up image. And then it's ready, it's set again, and then it starts paying attention to the PIR sensor. So that is the project of the week. Let me know if you have any questions about it in the chats. I'm going to be putting out a guide on that tomorrow, and you can see this one, there's a lot of ways that you could set this up physically. I'm going to unplug this now from USB power. So I figured you'd want to run this thing maybe during Halloween and have it plugged into USB power so you don't have to worry about batteries. So I have it just plugged into a USB adapter for power. And then I'm just using some Coroplast here. And I have a combination of zip ties. There's one zip tie holding just some of this wiring, and then I'm using double stick foam tape to stick everything on here, and actually it adheres really nicely. This corrugated plastic has a nice sort of matte-ish finish, which means that it's a bit grippy to adhesives. And I'll neaten this up a bit for the build, but rather than do like a 3D printed thing or a woodworking project, I figured you might just want to tack this stuff on the inside of your door frame or mount it to something like this and then hang it. And you could decorate this to look like something sort of convincingly Halloween-ish. So I'm going to get this frame out of the way here. And that's just sort of scratching the surface of the things that you could do using a PIR sensor and the HalloWing in a mode where it's ready to trigger something. You can imagine building larger flaps to release lots and lots of plastic ants. I know you can buy hundreds of plastic ants real cheap. I've done it before. Who knows? But you know, you don't want to scar kids permanently or coming up to your door at Halloween, or maybe you do, you sicko. I don't know. I didn't mean to just call you a sicko, I promise. It's just dark inner thoughts. So that is the, what am I calling this? A HalloWing jump scare trap. It's a trap. I promise you it's a trap. So let's see. What else have we got? Thank you, Julie's. That is great fun, you say. I think it is a lot of fun. I think you could also add neopixels to that if you wanted to. You want to do some blinking lights and get people's attention. I decided that using the speaker and the hiss was a good way to sort of give that 1-2 punch of like it hisses and then the thing falls, which gives a little more impact than just dropping something. Someone might not even see it or know that it's scary or dangerous until you get both the sound and the visual. A question in the chat about coroplast. It's corrugated plastic, and I think it's usually spelled C-O-R-O. P-L-A-S-T. You can get it at the, oh, let me switch camera back here. Geez, I stayed right there all day. Here we go. That's me. Hi. There I am. You can get these nice big chunks of corrugated plastic at a craft store. This is, what is this calling itself? Creatology plastic corrugated sheet. And that might be $4 or something for this 20-inch by 30-inch sheet. So it acts a lot like corrugated cardboard in a lot of ways. It's got fluting, it's got faces on either side, so you can, with scissors, you can go in and cut just one side of a face like that so that you can hinge it and create flexible pieces like tank treads. So that's corrugated plastic. It's also what a lot of signs are made of that are stuck in your front lawn. So if some political candidate who you don't agree with has stuck a sign in your front yard, you're within your rights to steal that corrugated plastic or keep the corrugated plastic and use it for your project. YouTube is buffering greatly. Oh no. We have some ideas about increasing the scary, like UV LEDs and luminescent paint on the ants and spiders. I like that. It makes them glowing creepy crawlies. Oh no, it looks like we're having broadcast problems on Twitch and YouTube. I am sorry to hear it. Well, hopefully you'll hear this because I'm going to give you a chance to save 10% on your Adafruit order. So if you head to the Adafruit store right now, uh-oh, the stream has stopped. Well, let's see, let me check my YouTube. Is it running? Oh yeah, it's gone weird. It looks like I still have audio going. Yeah, I think the streaming has just gone crazy. I'm sorry about that. Well, if you can see this, you're seeing it at 1044p, huh? That's no good. All right, it has stalled out. So I think that's a good time to end the show. So if you can see this, get 10% off in your Adafruit shopping cart by using It's a Trap. And with that, I will call it a show. So thank you so much for tuning in. For Adafruit Industries, I'm John Park, and this has been John Park's Workshop. Goodbye, everyone.